Welcome to the session on Object Oriented Design or OOD. In today's lesson, we will dive into the fundamentals of object oriented design, its key concepts, and how they form the backbone of modern software development. Let's get started. First, let us understand what object oriented design or OOD is. OOD is a design methodology based on the concept of objects, which can hold data in the form of attributes and behaviors in the form of methods. The core principle of OOD is to organize software design around these objects, making systems modular and easier to understand. Why do we use OOD? The primary reasons are to promote reusability, maintainability, and scalability. It ensures modular development, meaning that each object can be worked on independently, enhancing the flexibility of our system. Furthermore, encapsulation allows developers to manage complexity effectively. Let's now explore classes and objects, the foundation of OOD. A class is a blueprint for creating objects. It defines the properties or attributes and the behaviors or methods that the object will have. Objects, on the other hand, are instances of a class that hold actual values for those attributes. To give an example, consider a class named car. It may have attributes like brand, model, and year. You can create different objects of the car class, such as car 1, car 2, each with specific values for those attributes. Here's a simple code example to represent this. Moving on to inheritance, which allows one class to inherit the properties and behavior of another. Inheritance enables code reuse and allows us to create a hierarchy of classes. A parent class defines common behaviors and child classes can extend or modify these behaviors. Here we have an example where we have a base class vehicle with a method start engine. We then define a car class that inherits from vehicle and adds its own method drive. This demonstrates the power of inheritance, as car can use the start engine method from vehicle while adding its own functionality. Now let's talk about polymorphism. Polymorphism allows us to treat objects of different classes in a uniform way. There are two main types of polymorphism: compile time polymorphism or overloading, and runtime polymorphism or method overriding. Let's focus on method overriding. In our example, we have an animal class with a method sound and a derived class dog that overrides this method to provide its own implementation. This demonstrates how polymorphism allows different behaviors for the same method depending on the object that invokes it. Encapsulation is the practice of bundling data and methods that operate on that data into a single unit or class while restricting access to some components. This helps protect the integrity of the data by controlling how it can be accessed or modified. For example, we can define a class employee with private attributes name and salary. Public methods set salary, and get salary allow controlled access to these attributes, ensuring that data remains consistent and secure. Next, we have abstraction. Abstraction focuses on hiding the implementation details and exposing only the relevant functionality. This simplifies interaction with complex systems by providing a high-level interface while hiding the complexities behind the scenes. In this example, we have an abstract class shape with a pure virtual method draw. The class, the circle class derives from shape and implements the draw method. Abstraction allows us to work with different shapes without worrying about their specific implementations. To summarize, we have covered the key concepts of OOD, starting with classes and objects. Classes define the structure and behaviors of objects, while objects are the instances that hold actual data. Together, they form the building blocks of object-oriented design. We also explored inheritance, which allows us to reuse code and create class hierarchies, and polymorphism, which allows one interface to represent multiple behaviors. These principles are essential for creating flexible and extensible systems. Encapsulation ensures data integrity by restricting access to certain parts of an object, while abstraction simplifies complex systems by hiding implementation details. Together, these principles help developers create robust and maintainable systems. Now it's time to put what we have learned into practice. For our first exercise, create a bank account class with methods to deposit, withdraw, and check the balance. This will give us hands-on experience with object-oriented principles like encapsulation and methods. For the second exercise, design a class hierarchy for vehicles such as car, truck, and bike. Each of these classes should share common behaviors, but each type should also have unique methods. This will give us practice with inheritance and polymorphism. In the final exercise, implement a polymorphic solution for a shape class hierarchy. Create classes for circle, square, and triangle, each with a draw method. Use polymorphism to draw the shapes in a consistent manner. To conclude, object-oriented design is a powerful methodology for creating scalable and maintainable software systems. By mastering key components such as classes, objects, inheritance, polymorphism, encapsulation, and abstraction, we can design robust systems that are both efficient and easy to maintain. Thank you for your attention and happy coding.